Hey guys, welcome to my next video on basic electronics. And today I want to talk about resistors and resistance. I was going to talk about capacitor inductors, but I thought I want to keep this quite short and simple and only introduce a few new principles in each video so as not to overload anyone on new things. So what is resistance? So resistance is just anything that opposes the flow of electricity. So remember in our last video we talked about voltage and current, and so voltage is just there's too many electrons here, not enough electrons here, and current is how fast they're flowing, the electrons are flowing through something to balance themselves back up. So there's an even amount of electrons everywhere in the item or the circuit, say the battery. The battery's got too many electrons here, not enough electrons here. Hook up a wire between them, the electrons will flow to balance out how many electrons are on either side of the battery terminals. Now, resistance is just something opposing the flow of that current. So what happens is, say we talked about copper in our last video, and copper is really good at making or allowing electricity to flow because it has those free electrons in its outer shell that we talked about. And so those electrons just are all flopping around and can be easily pushed around to balance things out. So you can't really have something that is pure copper because even if you have some copper you make a wire out of it, it's not going to be 100% copper. There'll be some nickel in it, or there might be a little bit of some carbon atom, something else just snuck in, some oxygen's in there somehow, a bit of rust is going on. It's not going to be pure copper. And these other elements aren't so perfect like copper. They don't want their electrons to be flowing around. They're quite happy with their electrons chilling in their atoms. So the electricity comes flowing down the copper and it hits these other elements, and it's like, oh, I don't want to go here, tries to divert around and get through the easiest path. But that really slows down how fast our current is. And that's all resistance is, and resistors are. Things that are opposing our flow of electricity. So say we get our little carbon wire wrapped resistors that you find from J-Car or anywhere else. And all these are, they have an element in them, some carbon, that doesn't allow electricity to flow really well as some copper or something else in there that it does allow electricity to flow really well, and the electricity is like the electrons are like struggling to find their path through the carbon that they can't flow through, and so it slows them down. And that's all it is, and that's all a resistor is. You can imagine it like a pipe and the resistor is a valve, and a high resistance is like the valve being almost closed over, so hardly any water can flow through. In our case, hardly any electrons can flow through. So our water flow is very slow. So in the same thing, our current through our resistor is very slow because not much is getting through at all. Now, this is so handy in our circuits because we can use this simple relationship between how much current we've got and how much resistance we've got to control things in our circuit. Now, and this leads us to Ohm's law. Now, this very simply is that the relationship between our voltage, our current, and our resistance is always the same. It is a linear relationship. If you know the voltage and you know the resistance, you know exactly how much current you have. Because it's just a very simple equation, voltage equals current times resistance. V equals IR. Now, this equation can be shifted around, and here's a nice wheel that shows you all the different versions of this equation, but it's all saying the same thing. If I know two of the values, I'm going to know the other one. So, say you have something in a circuit where you need a certain amount of current. Well, if you know the voltage, you know how much resistance you'll need to make sure you get that certain amount of current. Right? And you can use different resistors to mix and match together. So let's talk about resistors in series or resistors in parallel. So say you've got two resistors in series, it's like two valves on a pipe, one after the other in a row. So they're very high resistances, they kind of add up together because the water can hardly flow through one, and then it travels along and hits the other one, and it can barely flow through that one. So by the time you get to the end, you've got barely any water flowing whatsoever because they're slowing the flow down. So our resistors just add up when they're in series. You've got 100 ohm resistance, and another 100 ohm resistor, now you've got 200 ohms worth of resistance. So you can kind of mix and match them in series to get different properties. Now if they're in parallel, it's a little bit different. And you can still use the same analogy that we talked about with water flowing. Don't get too caught up on the water flowing, it just gives you the basic understanding because electricity is not like water flowing, as you'll see with other items. But if they're in parallel, so our pipe comes up and then it diverts into two paths with two valves, and one on each path, and they're almost closed, while water will flow through one and water will flow through the other, and it'll match up on the other side, and you'll get more flow. So resistance, two resistors in parallel is less amount of resistance than if you just had those two in series, or just a single one of them by itself. So you get these ways of just modifying how you're getting your voltage and current. And you can use these passive components, and we call them passive components because they don't require any power to run. A resistor is just a resistor no matter what. It's just working. It just is a resistor. You get powered components like transistors or operational amps, op amps, which we'll get in later. They require a power source to do what they're required to do. These don't. Resistors just resist the flow all the time, just because of their makeup. There are some other resistors that are variable, but that's a bit more complicated. We're just talking about these basic resistors. So we can use these basic resistors to actually set the voltage we need in a circuit. So say we had 6 volts out of our battery, and we're like, well, wait a minute, my LEDs need 3 volts. So how am I going to get 3 volts out of my 6 volt supply? And you think, well, I know if I have 2 resistors in series, they add up together, right? So you've got 2 to 100 or 100 ohm resistors in series. It equals 200 ohms. You're like, all right, so I've got a voltage, and I've got this amount of resistance. That means I've got this amount of current. Right? I know I've got this much current flowing through this very basic circuit. So if I know the current, and I know each individual resistance, I know how much voltage is across each one of those 2. Because one eats up some amount of voltage, and the other eats the other part of the voltage. So in between the 2 resistors, we have maybe half the voltage, and we can get, by setting these resistance values, a voltage divider. So we can then get a certain amount of voltage out of our circuit. I don't know if that's a little bit too complex for you to not discuss the math behind, but you can just think about it like that half of it flows through this one and the other half flows through that. So you just get voltage out on the other side. So you can get a different voltage value, lower than the main one, out of two resistors. So you'll see resistors almost everywhere on your circuit. If I pick up a Arduino that I've just got floating around here, I can see a whole bunch of resistors, all controlling current values, all controlling voltage values. And these can be used in more complex circuits with more complex components. But basically, just for this video, a resistor is just something that is opposing the flow of our electricity. And if we know the value of our resistance and we know the voltage, we know the current. We can work that out very simply. This is a very basic equation. And if we know the current and we know the voltage, we can work out how much resistance must be in that section, because we can use the simple equation the other way. So that very simply is what a resistor is and how it's working in the circuit. If you have any comments, please leave them below. I'm also in the Aussie Arcade forum posting these videos, so feel free to post there. If you want any further information about how these work, or if you think it's a little too complex or what I can do to improve these videos, please let me know, and I'll try and implement it in the next one. Alright, thanks guys, and I'll see you later.